It is recorded. Okay, let's start. So hello everyone. So my name is Wei Yishang. Welcome to the second SERC Concordia seminar series. So today we are very lucky to have Dr. Alexander Serebrenik to join us. And Dr. Serebrenik is a full professor in TU Eindhoven in Netherlands. Right? So he is a big expert in empirical software engineering, mining software repositories, and other very general topics in software engineering. So a lot of his research deals with the diversity of software development, the communications, the interactions inside the software development team. Right? So today, I think he will give us an amazing seminar to share about his recent research about the opinion mining in software engineering. Right? So the floor is yours.
So thank you very much for inviting me, Wei. It's a great pleasure for me to be in Concordia, even so virtually. I know that the seminar has been allocated and planned for 1.5 hours. I don't think I will be going to talk for more than 50 minutes, but I'm going to stick around. So if you have any questions about this kind of work or any other kind of work we have been doing, please feel free to ask. I'm here for you, and it's a great pleasure for me to talk with you and to learn about what you think about those topics and whatnot. So when Wei has invited me, I've been actually doubting whether I should be talking about our work on diversity and inclusion or on talking about opinion mining. And ultimately, I decided to go for opinion mining, not because this topic is more important, both topics are very important, but it somehow seems that there is quite some attention to topics like diversity and inclusion, while the topics related to opinion might really benefit from more people looking into this kind of things and working on this kind of things to lift their quality of the work and to address the challenges that we have in this space. So what I'm going to do now, I'm going essentially to talk to you about what is it, what has been achieved, what are we missing, and how you can help. So there will be a call for action for you to try and to join the forces, because, you know, it's not only that we have cookies, we also have an interesting topic. Yeah, so opinion mining as such has started roughly 20 years ago. Dave et al. Have defined this opinion mining in context of search results as a process that for each item generates a list of product attributes. Think about features, think about quality, and aggregates opinions for each one of those attributes in terms of poor, mixed, or good. Roughly 10 years ago, people have started applying opinion mining and specifically sentiment analysis as one of the forms of opinion mining in the context of software engineering. So essentially today we have more or less 10 years of applications of sentiment analysis and related techniques to software engineering data. So something has been achieved, but there are lots and lots of challenges. Just a sec, yes. So this talk is based on an ongoing research, which we are conducting together with colleagues from the University of Svizzera Italiana, Bing Lin, Gabriele Bavotti, and Michele Lanza in Switzerland, with Nicole Novielli from University of Bari in Italy, and Nathan Cassé and I are from Eindhoven in the Netherlands. So what is opinion mining? So very often, opinion mining is used interchangeably with sentiment analysis, and even more specifically with classification of texts into 3 categories: positive, neutral, and negative, corresponding to the sentiment expressed in this text. And undoubtedly, sentiment is important. We know that affective states such as sentiment, such as emotion, such as mood, affect everyday people work. And this is true in general, and this is specifically true for tasks which require creativity and problem solving. And in general, you know, if you think about software development, this is it, right? So this is creativity, this is problem solving. So this is what software development is. And indeed, there are surveys, there are studies which show that happy software developers achieve better performance, that unhappy people, of course, tend to lose motivation, leave companies, and so on and so forth. So what we see here on the slide is an example of a sentiment analysis study, or actually emotion detection study to be more precisely, conducted by a company called Deep Affect on the Jira tickets. So already in this small example, I have mentioned two aspects of sentiment analysis, things which are related to product. So this was the original intention of Dave, right? We are talking about products, we are talking about features, those features are good or bad. And we are talking about people. Those people are happy, those people are unhappy, they're sad, and so on and so on. So on the people side, there is recently we have conducted a study with professional software developers in 5 Dutch companies. And we have observed that emotions, and in this case, the component of emotions, which is here known as valence, but in general, it's exactly what we are calling sentiments, so positive or negative, are related with self-assessed productivity. Moreover, this relation between sentiment and self-assessed productivity is becoming stronger in the afternoon. This is probably, I mean, we conjecture that this is related to the fatigue phenomenon, right? So as you are starting, as the day goes by, you are becoming more tired, and we know that fatigue impairs emotional regulation. So in the afternoon, people are more influenced by the emotions they experience, right? But of course, opinion mining is not only sentiment or is not only emotion. So here I'm referring to a classification of Pang and Lee, which was not designed for software engineering, but of course we are going to see that many of those things play a role in software engineering as well. So one of the things is indeed subjectivity detection. So are we discussing facts or are we discussing opinions? Another category is related to this joint topic sentiment analysis, which is also known as aspect-based sentiment analysis. And this was already mentioned by Dave in the very, very beginning, right? So when we are talking about identification of different aspects of different features of an artifact, and with each one of them, we are trying to associate a certain evaluation in terms of sentiment or in terms of positivity, negativity, right? So here we see an example of a mobile phone, right? So we have battery capacity, we have weight, we have design, but of course the very same kind of things can be done for instance, an API, right? We are going to see several examples later on during the talk. So taking a step back from individual opinions, discussion of viewpoints and perspectives tries to understand a general notion of an attitude. So for instance, when you are talking about political orientation, right, liberal versus conservative, or liberal versus socialist. So those things are not necessarily related to, I mean, they are kind of related to individual questions and individual crosses in the society, but they are also reflecting a general attitude. And in fact, there is a recent work which suggests that there are differences in cognition of people who are more inclined for to take more conservative stances and to take more liberal stances. And finally, the last category of opinion mining is an other non-factual information, which is a kind of catch-all category in the classification of Pang and Lee, where they put both emotions we have already touched upon, and humor. So humor in software engineering, humor in programming is an interesting topic. It's not very well studied. We also did not include it in this study. But if you are interested in this, it might be an interesting topic to think about together. So looking at this classification, looking at this body of knowledge on opinion mining in general, we wanted to understand how can opinion mining techniques, whatever they might be, support software development activities. And to answer this research question, we have decided to conduct a systematic literature review. So we have started with several well-known databases. Think about ACM Digital Library, IEEE Explore, Scopus, Elsevier, and so on and so on. We have used the keyword search. I'm going to show the keywords in a moment. We have identified several papers which judge their relevance based on the abstract, trying to be as conservative as possible. If the abstract suggested that the paper might be interesting, we read the full paper, which gave us the first set of results, and then we performed one snowballing iteration, meaning we have checked what papers have been cited in the papers we have selected. We followed those citations. We have again checked the abstracts and, if necessary, the full papers, and this has given us the second group of results. Of course, ideally, we should have continued this process till we have actually not been able to find more relevant papers. But as you can imagine, and I'm going to show the numbers in a moment, the effort required in snowballing iterations is pretty much prohibitive. So how did we start this entire process? As I mentioned, with a search string. So we started with an opinion mining. I already mentioned that opinion mining is used sometimes interchangeably with sentiment analysis, and we also included the word emotion because we know that emotions are considered more and more in the context of software engineering. We did not include humor because, as I mentioned, it's a different topic, quite distinct from those, and probably deserving a separate discussion. We did not include software engineering. So we tried, but software engineering turned out to reduce the number of hits from those databases quite significantly and missed several papers we believe to be important. So this is why we included software separately and developer or development separately. At some point, we thought maybe we just need to include software, but then, of course, it turned out to produce too much noise because any kind of sentiment analysis for whatever domain is typically supported by a software tool, which is performing this kind of task automatically. So just adding software will not capture our domain. So what happened with our numbers? So we have looked at the period from 2010 to 2019. We started this data collection process in early 2020. As you see, we have started with 795 papers, which as the first iteration produced 71 relevant ones. And then through snowballing, we got another 1,000 potential candidates, which led towards another 114 papers. So ultimately, we have preserved 185 papers for the follow-up analysis, which is not unheard of in terms of systematic literature reviews. But I'm very, very happy that we are doing this work with 6 co-authors, because you can imagine, right, if you are analyzing a paper, you need to analyze every paper with at least 2 people, just in case if there is a disagreement. And of course, it's quite a lot of work to do this manually. So for each one of those papers, we have tried to answer 6 research questions, which are essentially specification, refinement of the original question: how can opinion mining support software development? So we looked at activities in which software engineering activities has opinion mining been applied. We looked at tools and the reliability of those tools. We looked at comparison between tools because, sometimes people are trying to understand which tool is better, which is a kind of a very natural question. Data sets which can be used to evaluate performance of the tools, and concerns and limitations. So let us start with the first question. So of course the question is, what are software engineering activities in general? So there are lots and lots of ways of classifying software engineering activities. We had to start somewhere, so we decided to use an international standard, ISO IEC IEEE 12207, systems and software engineering, software lifecycle processes. So the yellow spots on the slide show lifecycle processes where opinion mining techniques have been used in one or more of our 185 papers. So you can see already that there are not that many processes where opinion mining has been used. And we expect that opinion mining can be beneficial for many other processes. So I'm just showing a couple of those examples on the slide. This list is by no means exhaustive. So for instance, when you are talking about disposal, so disposal is related to end of life of a system and to planning of end of life activities. So one way to plan this would take into account opinions of maintainers, opinions of users, opinions of maintainers of other systems which depend on our component, and this all can inform decision making. So essentially, informing decision making seems to be a recurrent topic when we are talking about the product perspective in context of opinion mining. But another example is an architecture definition. Again, we have multiple alternatives. Do we believe that this architectural alternative is better? Do we believe that that architectural alternative is better? This is a process which is inherently requiring opinions and requiring evaluations and arguments and whatnot. And of course, opinion mining can be expected to be beneficial in this domain as well. So the first call for action is to try to keep opinion mining and opinion mining ideas in mind in whatever software engineering work you are doing, to look at different directions, to look at your work through the lens of opinion mining, because this can be beneficial. This can help you to identify attitudes and opinions of developers with respect to whatever problem you are studying. Good. So let us take a closer look at the domains at software engineering activities where opinion mining has been applied. So just to show a couple of examples, right? If you are working in the requirements engineering field, several studies, for instance, by the group of Walid Malesh and Mitzal Guzman, so this kind of people have been looking at user feedback. You can think about Twitter, you can think about app reviews. So those texts provided by the users can be seen as a source of requirements. And in order to distill those requirements, we need to identify those opinions. We need to understand what people like, what people dislike, because things that people dislike might essentially suggest that there is a requirement somewhere there. Another example is related to knowledge management when we are talking about discovering rationale behind certain decisions, discovering rationale behind usage of an API, and so on and so forth. So let me show you two more specific examples. One is a work of Bin Lin, which has been proposed at ICSID 2 years ago, and this is POM. So as you see, POM is summarizing opinions of software developers about APIs. So you have an aspect sentiment bar chart, and the first bar shows the total picture in terms of positivity, negativity. And then each and every following bar suggests those aspects, right? So what do people think about reliability of this API or performance of this API and functionality of this API and whatnot. And of course, you as a user, you are not bound to look only at those scores, because POM also shows quotes, if I'm not mistaken, from Stack Overflow, where developers actually talk about this particular API and show their positive or negative remarks. What POM also does, and you see it on the right, POM also shows related APIs, suggesting that in general, from the total perspective, JSON simple might be a better alternative for Jackson and so on, right? So this is an example of application of opinion mining in context of design definition, when our stakeholder, our developer, is trying to decide which API to use. Should it be JSON? Should it be JSON? Should it be that? Should it be that, right? Another example is an older work of Andrea Di Sorbo and his co-authors. It is 2015. And this is an application of opinion mining in the context of quality assurance, right? So here we have several heuristics which have been designed by the authors in order to identify opinions in the user mails. So for instance, we see here an email, there is something wrong in the class structure, the resource locator doesn't work. So this is a problem discovery, right? So this is an opinion of the author of this email, of Andrew, suggesting that this is a problem. And then the next one, solution proposal, it's again an opinion, because I think it would be a good idea, and so on and so on. So this is yet another way of addressing these challenges. So as you see, opinion mining is going beyond classical sentiment analysis, positive, negative, and neutral. But of course, the most popular software engineering activity for the opinion mining studies is related to sentiment and emotion, detection, relating those variables to some performance variables or to some software engineering variables. And there is another topic which is in this human resource management area, evaluation of trust. So indeed, we have found 15 different studies that have tried to relate opinion-related variables, such as in this case, politeness, arousal, positivity, negativity, to software engineering variables, which are either related to artifacts such as issue fixing time, bugginess of a code, or to processes such as refactoring, build, and so on and so on. However, if you look carefully at the image, you will see that the results seem to be inconsistent. So for instance, we are talking about the relationship between politeness and issue fixing time. So there is a study which shows that polite requests, polite issues are associated with shorter fixing time. So this means that if you want to report an issue and hope to get your issue being fixed as soon as possible, you should be polite. There is another study which shows exactly the opposite, essentially suggesting that you should not be polite. So bullies are more successful, at least when it comes to issue fixing in this particular study. Another issue is this relation between positivity and issue fixing time. Again, if you are formulating your request in a positive way, then apparently the issue fixing time is going to be shorter. So the negative relation here, according to one of the studies. But there is yet another study which shows that this relation only happens for bugs that are being fixed during the weekdays, but not if bugs are being fixed during the weekends. So ultimately, even for the individual errors or conclusions, it's very difficult to know whether we can trust those results. And this is not a problem of opinion mining in software engineering per se. It's a general problem of empirical science, and we encounter those things in other areas of empirical software engineering, but we do have those problems. And those problems are typically related to operationalizations, tools, data sets, and analysis techniques. So operationalizations, don't forget that we are talking about high-level constructs, such as emotion, such as sentiment, such as politeness, and so on. They can be operationalized in different ways, and they have been operationalized in the literature in different ways, not necessarily consistently with each other. In the same way, even software engineering variables, which we are presumably understanding better than the social variables, are often open for different operationalizations. I mean, if you're talking about an issue fixing time, how do you even compute it? How do you exclude the issues which have been closed by bots? What do you do with the reopening? And so on and so forth. Again, different papers propose different operationalizations, or sometimes without doing it explicitly. And of course, this leads to different results. There is a major issue with the tools. I'm going to talk about tools in a moment, so let's postpone this discussion. Data sets, right? Very few of this kind of conclusions seem to be transferable from one data set to another data set, from one project to another project. Again, similar things have been observed for other areas in software engineering, but of course, this is happening here as well. And finally, analysis technique, and in particular, I mean statistical analysis techniques, which have been used to establish relation between different kinds of variables, are not necessarily consistent with each other. So essentially, different studies use different statistical techniques. They don't always match. So it's difficult to understand what is essentially going on. And the only possible solution I can think of, but I'm really open for any suggestions from your side, is to perform replications. There are several replication studies. Nicola Viel has published a couple of them. We have published a couple of them. It's not always easy to publish replication studies, but luckily more and more conferences are launching replication and negative results tracks, RENAIR tracks. And definitely, if you are a junior researcher trying to enter this domain, then performing a replication study might be a way to learn the ropes and might be a way to learn how those tools and how those data sets work. So good news is that people who are working in this domain are usually nice. Bad news, so they kind of will be happy to provide you with whatever they have. Bad news is that definitely if you are looking at early work on opinion mining in software engineering, it is not necessarily very rigorous, and neither in terms of analysis nor in terms of data management. So older data sets might not necessarily be available. So so as already mentioned, the next group of challenges is related to tools. So here is a big overview of all kinds of tools we have found in 185 papers we have considered in our systematic literature study. So those are tools which have been mentioned, not necessarily used, and the tools with an asterisk are commercial tools. So what do we see here, right? So first of all, we see that sentiment and opinion are quite popular as topics, followed by emotion. And for politeness and trust, we essentially only have a single tool for each one. And this has consequences. For instance, a tool for politeness has been designed for questions. So good news is that one of the data sets that it has been evaluated upon is on Stack Overflow questions. So it is in principle appropriate for the software engineering domain, but there is no guarantee that this tool will provide any kind of reliable results when applied to non-questions. So we need to think how to proceed. So here I have put in boldface the tools which have been used, not merely mentioned, in other in studies and other studies that have introduced them. So we see that quite a number of general purpose tools, such as centistrengths, NLTK, and so on, have been used in software engineering studies. And this is despite the fact that in 2017, Yongling et al. Have observed that such tools are not reliable when applicable to software engineering tests. And non-reliable means that the results produced by those tools tend to disagree with human raters, tend to disagree with each other, and tend to produce divergent results. So if you look on the image in the right part of the slide, you see different data sets and different relations established by different tools. And if you see that, so in this particular case, NLTK versus centistrengths, and in the red boxes, you see conclusions which can be derived by one of the tools, but not by other tools. So for instance, when it comes to known issues, using NLTK, one could conclude with all the statistical significance you want, that positivity leads to longer discussions. Positive is longer than negative. If you are using a different sentiment analysis tool, the direction of this relation is simply swapped. So essentially, don't use general purpose sentiment analysis tools for software engineering data, software engineering texts. And this is in particular striking if you observe that many software engineering tools have not been used. Of course, some of those tools are more recent, and since our data collection was done in 2020, more recent tools from 2019 did not necessarily have an opportunity to be discovered by the colleagues and might be used by the colleagues. But beware, right? These are different tools, and it might be a good idea to look at them. Moreover, software engineering, and this is an observation from Nicole Novielli at MSR 2020, cannot be seen as a uniform domain. So different software engineering applications require different tools or tool adaptations. And if you are thinking about it, it's not so surprising, because the way people communicate on Stack Overflow is quite different from the ways people communicate in app reviews. So if you are frustrated and essentially you are shouting, this app does not work, it crashes, my life is not possible, is a very, very different kind of communication as opposed to Stack Overflow, where you are expected to adhere to certain norms of professional conduct, right? Let alone that Stack Overflow also prescribes how to behave on their platform. So ultimately, this means that before you are applying a software engineering, a sentiment analysis, or in general opinion mining tool designed for a software engineering context, you need to carefully check what was exactly the context it has been designed for. And this is what happens. So in the first column, we have our tools. This time, the industrial tools are typeset in italics. The general purpose tools are typeset in italics. As before, those with asterisk are commercial tools. And every cell corresponds to a study. So those cells can be green, red, and gray. Green cells means that the tool has either been validated, or at least it has been adjusted to the domain based on the author's expectation. So for instance, two studies in 2014 used a general purpose centistrengths tool, but because they knew that they are going to apply it in the software engineering domain, they somehow fiddled with the tool and adjusted it to try and capture the specifics of the software engineering language. So the red two cells are, of course, the cells where no such verification or no such adaptation has been performed. And finally, the gray cells are the cells where the tool is applied to the same kind of data, to the same data source as it has been designed for. So essentially, there is no need to adjust the tool. At least there is no obvious need to adjust the tool. And of course, the first software engineering specific tools for opinion mining appeared in 2017. So everything which is before 2017 and maybe in 2017 itself could be expected to be red. So those two green studies are really a nice discovery. But from 2018 onwards, we kind of hope to see more of the green or of the gray cells. And you still see that still in 2018 and 2019, they have papers which are applying centistrengths, papers which are applying an LTK, and so on and so forth, which are general purpose tools. So beware. The main message here should be, please check the tools before using them. If the tools are broken or unreliable, so will be the results. And of course, we need better tools. So the question is, of course, what does better even mean? Which tool is better? So luckily, there is a series of papers which have compared different software engineering, different opinion mining, or specifically sentiment analysis tools on software engineering data. So you see that most of the time, researchers are looking at issue reports, at code reviews, things about Garrett, right, and Stack Overflow posts. So those are the most popular domains. If you are looking at the metrics, there is quite some disparities there. Some people are talking about accuracy. Some people are talking about agreement, for instance, measured by a weighted kappa. Other people are talking about some form of F1 metrics, right? So there is a disagreement there. The underlined tool in each row is the tool which has been reported to show the best performance in this particular study or this particular data. The tools in the boldface are the tools which have been proposed. So for instance, P23 has proposed Sentimoji, and it has shown that Sentimoji outperforms all other tools on their dataset. Of course, what we see here, so if you look carefully, right, you see that every single time we see a tool in the boldface, it is underlined. So every single time a paper is introducing a tool, it is shown to outperform state-of-the-art tools. This is, of course, a reflection of the publication bias. If your tool does not outperform the existing tools, you simply don't have a paper. So let us exclude those rows for the moment. So, right, we got less rows, and we still get not very consistent results. So for Stack Overflow, it seems that we are good, at least for studies P128 and P166 have compared exactly the same four tools with respect to exactly the same metric, and they obtain the same result. 74SD outperforms the remaining three. But for instance, for code reviews, it's much less clear. So again, we have the same P128 and we have P12, and they seem to disagree. It's either CentiCR or 74SD. Ultimately, this means that we need more and more careful comparison studies. It's not just different tools on different data sets. It's also different comparison methods, different preprocessing techniques. Some tools take into account emojis, some do not. Some tools replace file names and URLs and names of contributors by meta tokens, some not. some tools are very sensitive to length of the text and show better performance on shorter fragments. Some others are more or less ignorant of the length, right? So essentially trying to tease out the impact of each one of those decisions on the ultimate result of the tool is non-trivial, and it's a challenge we need to address as a community. So as already mentioned, many of the tools we are talking about are essentially classifiers. And as such, they are of course sensitive to the data they have been trained on. And this is why in our next research question, we wanted to understand which data sets are available to train those tools, to retrain those tools, or to evaluate them. And when it comes to the data sets, we only looked at the data sets which were available at the time when we've been collecting the data. So I already mentioned that popular data sets are related to code reviews, Gerrit, to issues, Jira, and to Stack Overflow questions. But we do have more general purpose data sets derived from Twitter, derived from Reddit, to the extent that they discuss software engineering related topics. But of course, there are more data sets. And it's not that just there are more websites, but rather that those websites can be expected to exhibit a different communication style. And as such, they will be probably showing sentiment and emotion in different ways than the ones we are studying. So for example, we have informal communities of software developers. DevRand and Dev are two examples, but there are more, right? So those are less formal communities. For instance, on DevRand, people are joking, they're complaining, that you would expect to see more frustration on this kind of websites, and subsequently being less constrained by those norms of professional behavior, which I've been already mentioning before. A very different data source would be Slack. So Slack is of course designed for teams. Even so, it is often used for broader communities. So if we are working in a team, maybe our familiarity with each other would allow us to express emotion, express sentiment more freely, as opposed to asking a question to a random stranger on Stack Overflow. Another group of websites and another group of developers which we absolutely do not cater for are developers who do not communicate in English. All the tools I've been talking about have been designed with English in mind. Even so, we know, of course, that there are lots of software developers who prefer to communicate in Chinese, in Portuguese, in French, in Russian, and so on and so forth. And while outside of the software engineering domain, there is quite some work on opinion mining and sentiment analysis, and even advanced forms of sentiment analysis for languages other than English. This trend does not seem to have reached the software engineering side of this community. I guess it is simply because of the size of the community, right? So if you are talking about sentiment analysis or applications of nature language analysis in general, there are lots and lots of people who are doing this kind of work. They have evaluation campaigns. For instance, there is Evalita, which is a well-known evaluation campaign for Italian. Nothing like this exists in the software engineering domain. Another challenge we have is related to the amount of the text we have. So when we are talking about sentiment and emotion, so the data sets which are labeling sentiment and emotion on the sentence level range between roughly 340 and 4,000 sentences. And 4,000 sentences is quite a lot already. If you're talking about texts, and the text here can be a comment or a post or something like this, then it is more or less in the same range. So you need to understand that labeling this kind of data sets is a manual process, and it is difficult because it requires training of the raters, right? We are going to talk about it in a moment, but in general, you need to train your raters. You cannot just assume that your raters would somehow inherently know what is positive, what is negative, or what is this emotion, what is that emotion. And then you just need a large group of raters to ensure that their rating is consistent. So this has been a major obstacle for this field for some time. But in 2019, several papers have suggested combining those small data sets with much larger general purpose data sets, which are not necessarily even derived for software engineering data, or pre-trained models coming from them, right? So it's of course not, again, it's not something which is specific for this domain, but this idea of transfer learning or this idea of pre-training, so reusing those pre-trained models comes to the domain, to our domain as well. The only problem here is that unfortunately our data collection, as already mentioned, ended in 2019. So in 2019, we have only seen proposals along those lines, rather than fully blown evaluations and comparisons, for instance, of deep learning solutions and traditional machine learning solutions. And finally, the last challenge, which is related to the data set, is inconsistency in human ratings. So if you're asking people to evaluate a statement, is it positive, is it negative, does it express anger, does it express sadness, you cannot just assume that people will be providing consistent ratings. One of the reasons why it happens is because of the negative facts. So for instance, we have a bug report. One rater might decide that a bug report is by definition negative, because as software engineers, we know that bugs are undesirable. So everything which is discussing bugs should be negative. Another rater can take a more emotional stance and say that a statement is only negative if it reflects a negative emotion. So if I have a text which says the system crashes when x equals 7, it's a neutral text. It does not, it is void of any emotion, and in particular, it does not represent any kind of negative emotion. As opposed to it, if you have a text which says the system crashes, x equals 7, I'm perfectly unhappy, and so on and so on. Your system is unuseful or useless or whatever, right? So this can be a reflection of anger, this can be a reflection of frustration, and as such, this text should be seen as negative. And there is no good decisions here or bad decisions here. It is your decision as a researcher, what would you want to consider to be positive, what would you want to consider to be negative? You simply cannot expect your raters to have an innate understanding of those notions and to be this innate understanding to be consistent with each other. In fact, Nicole Novielli has shown that if we train classifiers based on model-based annotations, so essentially when we have a very clear theoretical model of what constitutes this emotion or that sentiment, so those tools will outperform tools which are trained on data sets with ad hoc annotations. So if you want our raters to be consistent, if you want our seagulls to fly in the same direction, we need to provide them with a scaffolded model of sentiment, of emotion, or whatever kind of opinion we essentially expect them to rate. So this means that from the data perspective, we need more data, and more importantly, we need better data coming from more diverse data sources, supporting more languages, better aligned with goals of the study. We cannot just blindly take a sentiment analysis or opinion detection, emotion detection tool from the shelf and expect that this tool will provide answers which will be aligned with our specific research goals. So to summarize, I've been talking about a systematic literature review we have conducted on opinion mining in software engineering. And there are quite some challenges in this domain. As a community, we need to look at things which are related to new applications, to providing more reliable machinery in terms of building more reliable tools, replicating previous results in order to understand what do we know, what don't we know, and indeed going beyond the current boundaries in terms of the data. So thank you very much for your attention, and it will be my pleasure to answer questions.
Okay, so let's give applause to Alex. So thank you for the talk. So for the audience, so if you want to ask a question, please raise your hand, and then I will call your name and unmute you. Right. So I may not know who raised hand first and who raised hand second, but I'll try to keep in track. So if you don't have a mic, and if you want to ask questions anyways, you can always type the questions in the chat and I'll look it in, right? Okay, so I guess the first one is Ahmed. You can make it.
Hi, thank you for the nice talk. Actually, it was an interesting to learn about the variety of opinion mining tools that are specialized for the SE domain. So basically, my question is about applying those tools in the chatbots that are used by the software engineering practitioners, especially that there are some studies shows that people interacting with bots or chatbots is different than human interaction. So Alex, so in your opinion, do you think that there are tools available that can be integrated with the chatbots operating in the SE domain? So for example, if a user is unsatisfied with a chatbot response, we can take a certain action such as contacting the user, or maybe the chatbot or the bot can ask the user a question, okay, on how to improve the response. So what do you think about it? Thank you.
Well, thank you very much for this question. I mean, I think that you can integrate many of those tools in your chatbot scenario, but again, before integrating a tool, double check whether they are producing results you expect. Chatbot is probably expected to respond in a dialogue fashion, right? So it's also relatively short sentences with a lot of context being shared by the parties. This is not an application domain those tools had in mind. So yes, technically speaking, of course you can integrate those tools, but before integrating them, double check and triple check what's happening. I don't know whether it answers your question. Right, so you probably cannot retrain, for instance, in the context of the, so you can either retrain it first and then hope that you can apply your tool on the, you know, in an online fashion. Or you are assuming that your tool is, for instance, non-supervised, right? Your center strength is E. Like, I mean, you have some options there as well, right? So depending on what you want.
Okay. All right. I think Peter.
Hi, Alex. Great talk. Thanks a lot. Yeah, I haven't thought about sentiment too much since I think like 2006 when we applied LIWC to Apache. So it's been a while. So it's interesting to see like so many great works in this area. One of the things that I've been really interested in is turnover, and we kind of assumed that you would see sort of negative sentiment, negative opinions, potentially driving people to leave projects. I mean, with the example of like Linus Torvalds, berating people and driving people off. One of Bram's students, I believe Isabella, was kind of looking at like, can we actually sort of quantify this politeness and so on. And one of my students, actually Fahime, tried to just create models to predict when people would leave, and just using sort of the standard MSR like churn and complexity and all these other kinds of things. The models were awful. Like you could not predict when someone was going to leave. And I was like, oh, great. Maybe we can combine this with sort of sentiment analysis. And again, the models were terrible. When we took Isabella's tool, we were just not able to predict when people were going to leave. And I guess my question to you, well, then Fahime went and actually looked at like when people left and the events and whether, there was any indication of this in like the chat rooms, in the bug reports, in the commit logs, and it was just not there, right? And I think, for turnover, I think maybe, people leave for reasons totally separate most of the time from the project, right? Like they get a better job offer somewhere else, etc. Do you think, and this is my question, do you think that the sentiment and opinions are there in the written text? Like, do you think that we're actually going to, I mean, I know a lot of tools didn't work properly. I feel like it's very difficult to create these tools. Do you think it's in the written text, and where do you see, like, if not, where do you see this going, and how are we going to use it?
Yeah, great. So thank you very much for the question, Peter. I mean, I really like it. So indeed, for turnover, well, we know that frustration leads to turnover. Frustration is definitely not the only reason leading to turnover, right? There are studies of turnover intentions, why people leave companies, why people leave open source projects, and often those are simply personal reasons. Or if it's, for instance, an open source, my company just stopped investing in this project, full stop. So there is no real frustration of any kind, right? That's one story. Another part of the story is that those famous or infamous norms of professional behavior, even if the frustration is there, it is not always manifesting itself in the channels we like to look at. Because, you don't want to appear unprofessional. So this means that if you are, usefulness of this kind of tools strongly depends on your scenario and on your data. If you are going to look at frustrations, whether in context of turnover or not, you need to look at sources where you can find frustrations. So you need to look at DevRand, you need to look at Dev, you need to look at other kinds of informal communities. And then I don't know whether you can get actual turnover intentions out of that, but you might be able to figure out what frustrates developers. And I guess that those will be their wonderful managers, their equally wonderful clients, and ultimately other human beings. So if you are looking at things along at more popular platforms, such as Stack Overflow or issue trackers or whatever, then the name of the game becomes how to phrase your question. And it's not so much about emotion, but more about politeness, more about what language you use, and so on. And I don't know whether, and I guess that opinion mining is more interesting there in its broader sense than specifically sentiment. I mean, there is the work of Nicole Novielli and I think it's Fabio Califato is the first author on how to ask questions on Stack Overflow, right? So they used some of those sentiment analysis machinery as one of the variables there. But it's not, you can try to see this as a guideline in different contexts. So yes, you can find this sentiment and emotion, but the more professional your channel is, the more dominant the neutral sentiment or lack of emotion will be. This is also the reason why we have recently started looking at biometrics, because developers experience those emotions, but do not necessarily express them. So we have conducted a study when we asked professional developers to wear a wristband, an empathic wristband. Think about some form of Apple Watch, right? Fancy Apple Watch. And to record their biometric measurements, such as galvanic skin response, heart rate, beat, and so on, heartbeat rate, sorry, and so on, and compare it with, for instance, whatever they report in terms of emotion, in terms of productivity, and so on, right? So this is a different thing. So one of the interesting questions which I've been trying to look at, but I mean, we never got to study it formally, is a discrepancy. So what happens when our poor developers experience frustration but don't dare to express it? Because this would suggest that they are spending some kind of energy to mask their negative emotions or to exaggerate their positive emotions, because they're supposed to welcome people to the community. I mean, I don't care about those newcomers, I just want to program, right? So why am I supposed to be so welcoming, right? So this kind of phenomena have been studied in psychology under the label of emotional labor. And emotional labor is, of course, not only about discrepancy, but also about frequency of this discrepancy and about what kind of expectations out there. So it's an interesting topic. If you are interested in this kind of work, we can always brainstorm on how to do it together. But it's not an easy thing to study, because you actually need access to two parallel channels, to the biometric channel and to the textual channel.
Great answer. Thanks so much for going into that. For the biometric stuff, like how complicated is that? Like, is it just an Apple Watch, or is it some specialized watch? Could you use simple, like off the shelf, like cheaper Android watches? Like,
does this answer your question a little bit?
I can't hear you.
Yeah. So there are different tools, right? So we used Empatica E4, which is a tool, I called it Apple Watch because it looks like one, but it's not really Apple Watch. It's Empatica E4. It has been evaluated and certified for medical applications, such that at least on this side, we are as good as we can be. Why did we use Empatica? Because it's a collaboration with Nicole's team, and they have conducted a lab experiment when they used this wristband and they used an EEG headset to check correspondence of what they measure with emotions as triggered by whatever videos, right? So from their lab experiment, it turned out that this Empatica E4 is sufficiently reliable for this kind of context. So if the moment you are changing your context, you don't know what you do. Other biometric measurements can be problematic. So you often have instruments which require you to to wear some kind of finger rings, right? And the problem with those finger rings, it's perfectly fine for classical medical experiments, but not when you are supposed to be typing, right? The moment you are typing, your fingers are moving and your measurements become unreliable. So you really need to have a very non-invasive sensor to obtain some form of measurement which would be even acceptable for your developers. So we've been very lucky to find those 5 companies ready to work with those empathic wristbands, but it was quite a logistic story, right? We need to bring those wristbands, we get back those wristbands. Each wristband costs roughly 1,000 euro. So you are kind of restricted in how many wristbands you have, and so on and so forth. So it was not an easy story logistically, but you can do it.
That's very interesting. And I think you step away from just opinions and you start to get into things like wellness. Like,
oh, yes, it appeared in it's accepted at Towson. So if you want, I can send you that.
Yeah, that's great. Because yeah, that's, I guess, actually, I'll let other people ask questions. Sorry.
Okay, so I'll ask a question first.
Yeah, and well-being, right?
So I have two. Actually, I have 2 questions. So one is more higher level, right? So seems like the software engineering community depends on a lot of the tools and techniques that are developed by the NLP techniques, right, to do these classifications, right? But based on your, I think based on your talk, also my understanding is like sentiments and opinions and all these things are very complex, right? But NLP techniques often just treat them as a classification problem, right? A lot of times, like humans' emotions are very complex. Like I can be sad and I don't know, somehow happy at the same time, right? So I think my first question is, do you think the NLP community is ready for this? Like if they're not even ready, then like we cannot follow them, right? So what's your opinion on this?
Well, yes and no, right? So the NLP community is in general more ready than we are, because of course there are many more resources there and many more people working on those things. But there are challenges which are simply challenges for any kind of sentiment or emotion detection. One of those challenges is sarcasm. It is really, really hard to detect sarcasm.
Yeah.
Sometimes, I mean, you have specific cases of sarcasm which are relatively easy to detect. For instance, when you have in Twitter, you have discordant sentiment in the text of the tweet and in the hashtag. For instance, I don't know. I have received the best grade ever, hashtag not true, or something along those lines. Right? So when you have this clash between the text and the tag, then at least you have a relatively easy way of identifying your parts, and then you can say, okay, they disagree, so apparently it's sarcasm. But of course, there are so many more ways of expressing sarcasm. And our wonderful software developers are so good at it. When you're just reading their communication, they can be so horrible without being, you know, they are so subtly horrible, right? So that essentially leaving the tools no chance of detecting.
So what, like, do you think that's a huge challenge for, like, how much would that actually impact the research that we do? We can't hear you, sorry.
Well, you know, I'm afraid that it's a matter of attitude. So in a sense that I think it's, can you hear me now?
Yeah, here we can hear you now.
Can you hear me?
Yep. No, you're gone.
Okay, good. So I think it's a matter of attitude in a sense that I'm very happy when this kind of tools can help even in some situations. I don't think that we can ever expect this kind of tools to resolve all possible challenges and all kinds of communication problems in the text. If it can capture at least something, if we can flag some form of extreme behavior, then it's already good news. Neutral sentiment is really, really difficult to detect.
Okay. All right. I guess my second question is more to the details, right? So when I did some related research, for example, like studying the sentiments in the app reviews, right? I just found like for a newcomer, there's a lot of pitfalls. It's not easy to start, right? So although you have a lot of tools, like there's a lot of things that you need to be worried about. Like for example, do I study the sentiment at the sentence level or at the post level, right? At the post, I can have sentences, like the first sentence is saying, oh, this is a great app. And the second sentence can say, oh, but this is buggy or whatever, right? So you can have a lot of different findings if you studying this in different levels, right? The other one is different people may have different thresholds for these sentiments expressions, right? So like some people are more polite, some people maybe are more on the edge. So I'm just wondering, like for suggestions for the students audience in the seminar, like do you have any suggestions about is there any like pilot studies we can like follow, or like a cookbook? So what's the best practices of conducting this research?
Thank you for the question, but I mean it's essentially $1 million question, right? A lot of those things depend on what are you looking for, right? So poem, which I already mentioned, it tries to solve this problem by looking at different aspects, right? Some tools are trying to detect aspects and sentiment at the same time. So with aspects, your life is easier if you know what those aspects are in advance. So if you are looking for usability, if you are looking for security, if you are looking for reliability, you at least know what are you looking for, as opposed to the situation when you have text and it can have any kind of aspects. You have no clue what are they talking about. And from there, you also somehow need to tease out those individual aspects. This is a much more difficult task. You have sentences with mixed sentiment or with mixed emotion. From the perspective of the wonderful classifiers, those sentences are usually simply excluded because you don't want to confuse your classifier. From the perspective of an application, of course, that's a more tricky thing. Most of the tools use a single score for entire sentiment. I mean, it can be a class, it can be a value. Sentistrengths and Sentistrengths SE are exceptional because they score this every statement they are getting through 2 scores. One is from non-positive to positive, one is from non-negative to negative. So essentially positivity and negativity are kind of independent, and then you can capture sentences with mixed sentiment if this is what you are after. But unfortunately, as many of those studies have shown, Sentistrengths SE is not really the best option in terms of any of those evaluation metrics on many of those data sets. If you are entering this domain, I think that the most important thing is to try to think very carefully, what do you want to capture? Are you looking at product? Are you looking at person? Are you looking at emotion? Or are you looking at product characteristics? This would be the first step. The second step once you have decided what you're looking for, select a small data set, I don't know, 20, 25, 30 statements or comments or whatever you are working on, and label it yourself. And ideally ask your friend to label it independently. And try to see where you agree and where you disagree, and what do those disagreements mean? Is it very clear for you what are you actually labeling, going back to question 1? Do you want to use or create a model of sentiment? For instance, there are all kinds of models of emotion in the psychological literature. You can reuse one of them. But you can also decide that, you know, you are working from a different perspective and you actually propose a different model. I mean, some of those models from psychology are really strange. In a sense, for instance, one of the popular ones considers gratitude as a form of love. So this is already non-trivial, but then the consequence of this is that suddenly you have software engineering papers which are saying there is a lot of love as an emotion in our data set because developers are saying thank you. It's really counterintuitive. I mean, I understand how people get there, but it doesn't make any sense for me as a, you know, as a human being. So you need to decide what you want. You need to check that your understanding is in agreement with your data set, and only then you can say, and now I'm going to use tools or not, and if I'm going to use tools, which tools am I going to use?
Awesome. Yeah, thanks for the advice. Okay, I think it's already 11:17. So there's no more questions. We'll thank Alex for this great talk, and thanks for your effort in this.
Peter had lots of.
We lost you.
Hello, sorry.
It's cut off. I think it's cut off.
Thank you very much for inviting me. It has been a great pleasure.
All right. So thanks again. Yeah.
Thanks for a good talk. Really appreciate it.
Yeah.
No, I'm still here. I just stopped sharing my screen. So thank you very much for inviting me.
Okay. All right, everyone. So thank you. And I think that's the end of today's seminar. So thanks.
And if you are interested in this, just drop me an email. Bye.
Awesome. Thank you. Bye.